Hello everyone, welcome to this lecture video. In this lecture video, going to discuss memory management of the operating system. And in the operating system concept, we have the memory management. In the memory management, you have the what is memory management, what is swapping, what is contiguous allocation. In this memory management, we are going to cover paging and segmentation with paging. We start with the memory management. Here in this slide, we are going to discuss what is the main background behind the memory management. A program must be brought into a memory and placed within a process for it to be run. So input queue, collection of process on the disk that are waiting for to be brought into a memory to run the program. Here the user program go through the several steps before running. Finding instruction of data memory. So compile time, load time, and execution time. So compile time, we have the memory location known priorly. Absolute code can be generated. So if having the load time and the execution time, these things can have the different kind of process. Compile time, load time, and execution time. So in the multi-step process of user program, we have a source program, compiler, assembler, object module, then extra things. In this multi-step process of user program, look at the screen. In this screen, we have the architecture diagram of compiler processing of a user program. So first, a source program can be sent to the things to the compiler or assembler. In that, we have the object module. So object module, we have the linkage editor and load module. So other object modules should be connected to the linkage editor. This is a compile time. Then load time, we have the different kinds of process. In this we have the linkage editor, load module, and loader. So dynamic loader system library. So dynamic linking in memory, binary, and memory image. So execution time and other system we having these kinds of process. So the logical versus physical address and spaces. So in this topic, discussing about the logical versus physical address space. The concept of logical address space is that is bound to a separate physical address space. Normally, logical address and physical address generated by the CPU and also referred to as virtual address. So generally, the logical address can be referred to as virtual address. Physical address can be seen by the memory unit. So both the addresses are in compile time and load time, addressing binding to the schemas. So logical, virtual, and physical address after the execution time address binding the scheme. So these are about the logical and address space in the memory management. We have the memory management unit MMU, and other things we having. So hardware device that maps into the physical device. Other things we have the MMU scheme. The value is reallocations registered in order to every address generated by the user processed at the time it sent to a memory. The user program deals with the logical address. It never sees the real physical address. Then followed with the dynamic reallocation using reallocation registers. CPU have a logical address 346 and the reallocation address having the MMU, physical address having the things. So in this lecture video, we will discuss the dynamic reallocation using the reallocation registers. So then dynamic loading. Dynamic loading is nothing but the routine to not loaded until it is called. So better memory space utilization. Unused routine is never loaded. Useful when large amount of code are needed to handle infrequently occurring cases. So this kind of dynamic loading can in this PPT we can able to understand what is dynamic loading. In the memory management, the operating system have the dynamic loading and other things. So no special support from the operating system is required. Implementing through the program design. So dynamic linking we have linking postponed until execution time. Small piece of code stub used to locate the appropriate memory resistant library routine. Stub replaces itself with the address of the routine and executes at the routine. So operating system needed to check if the routine is in process memory address. Dynamic linking is particularly useful for library. And the overlays. Next we can talking about the overlays. It is keeping memory only those instruction data that are needed to at any given time. Needed when process is larger than amount of memory allocated to it. So implemented by user, no special support needed from the operating system. Program design of overlay structure is complex. The overlays for two pass assembler. Pass 1 and pass 2. Simple table a common routine, overlay driver. So pass 1, pass 2, we have 70,000 and 80,000 passes. We are having the simple table and common routines and overlay driver. So these kind of overlays of two pass assembler, pass 1 and pass 2, we are having the two passes overlay of assembler. So it can be able to see in the architecture sample overview schematic diagram of overlay for two pass assembler. Then swapping. Before swapping, in this lecture video we have discussed about the basic things of memory management, how the logical and other process, for example logical address and physical address, how will you allocating the space in the CPU. These we have discussed in this lecture video. Thanks for watching. We can continue this next topic in the next video. Thanks for watching.